Number 11. A piece of unknown solid substance weighs 437.2 grams and requires 8,460 joules to increase its temperature from 19.3 degrees Celsius to 68.9 degrees Celsius. And then we have letter A. What is the specific heat of the substance? Okay. So the question is, what's the specific heat, right? And usually a specific heat is only 2 letters. In my case, I know specific heat as a lowercase s. You might know specific heat as a lowercase c, but either way, we're still going to get the same answer, whether we say that it's an S or a C. I'm just going to use it as an S for specific. Now, what else did they give me? Well, let's just go through the question again and just write down all of the units and the variables that they gave me. They said that we have a piece of unknown solid substance weighing 437.2 grams. Any type of gram value is a mass, so I label that as M. So for letter A, I have a mass value in M of 437.2 grams. Now, this substance, which weighs this, has it requires 8,460 joules, right? That's a energy value. Joules is energy. And now in this case, we're increasing the temperature, so we're adding heat, right? So heat energy is a Q value. So I also have a Q in here. I know that my Q is 8,460 joules. Now let's keep going. We need to increase the temperature or the substance is going to get hot, right? It's going to go from 19.3 degrees Celsius to 68.9 degrees Celsius. So I have 2 temperatures. So I'm increasing the temperature. So that means that I have an initial temperature and a final temperature. The starting temperature was the 19.3, and I don't like how there's like a degrees Celsius down over here. This should be grouped with this. So I have 19.3 degrees Celsius, that's the start. So I will call that a TI, I for initial. And then I have a 68.9 degrees Celsius, that's my final. That's what I'm bringing the temperature to. So that's a TF, F for final. So I have a TI of, not the rapper, by the way. What happened to him? What happened to TI? Let me know in the comments. He was good. I liked his music. TI equals 19.3 degrees Celsius, and TF equals 68.9 degrees Celsius. Okay. And now the question's asking for what's the specific heat. I'm going to label it as S. So S equals question mark or an X value. Usually when I do algebra, I like to just put it as X. So I'll just say that that's my variable. I'm solving for the specific heat. Now, I go through all my formulas that I've learned in chemistry up until this part, right, in the chem course, and I say, is there a formula that relates a mass with the heat, with the Q? I have temperatures, I have a specific heat. Yeah, there's a formula, and it's this guy, right? I'll bring this over here. It's Q equals MS delta T. Now, you might know it as Q equals MC delta T if you're using C for a specific heat. It's the same formula. Let's just write out what each one of these means. The Q, just like we said, was the heat energy. And if we're using this formula, that has to be in joules, which it is, right? We have it in joules, so check. The M is the mass. So this has to be in grams, and they gave it to us in grams, right? So that's a check. The S, which I'm using, is the specific heat. Now, this is what we're solving for, so that's all good. Just know that the specific heat is units of joule per gram times Celsius. Whole bunch of things going on here. And then we have this triangle T. This is a delta T. Delta is Greek for just a change, right? So it's the change in temp. So I'm just going to say change in temp. And that's always in degrees Celsius. For this formula, you never convert to Kelvin, mainly because the units for specific heat has a Celsius in it. So Celsius got to go with Celsius. So the first thing we got to figure out is, well, what is the delta T, right? If I'm going to use this formula, I got to know what delta T is. I have an initial and I have a final. From there, I can find out my delta T. just know that delta T, the change in temp, is always final minus initial, not initial minus final. So TF minus TI, and let's just plug in and see what the change in the temp is, the delta T. The final temp was 68.9 minus the 19.3. I don't put any units when I do my math, my calculations, because I just do a check and make sure that I have the right units. And if I do, I don't put them in. I just like numbers when I'm doing the math. So 68.9 minus 19.3, we get 49.6, and that's in degrees Celsius. Okay, so we're solving for S. We should know all the other ones, which we do. So Q equals ms delta T. Q was 8,460 equals the mass, which 437.2. We're solving for S, so I'm just going to put an S here. And then my delta T, which I just found out, was 49.6. Let's just use algebra, right? I'm going to multiply the mass and the delta T, so 437.2 times 49.6. I get a big number, but that's okay. 21,685.12, and that's being multiplied by S. So if I want to get S by itself, I have to do the opposite. So I have to divide by 21685.12, divide by 21685.12. This number cancels, and I'm left with S, or, you know, if you did put it as a X, right, because that's what I said I would do, doesn't really matter. You would say that your S is your specific heat, which is whatever that number is, 8460 divided by that big number. And I need 3 sig figs, right? Because the lowest number that I have here is 3 sig figs. So I'm going to say 0.390, and that's in joules per gram degree Celsius. And that's my final answer for A. So my A, they asked for what was the specific heat. It was 0.390 joules per gram Celsius. So that's the final answer for A. Now for B, it says if one of these substances are found on table 5.1, what is its likely identity? Well, just know that you can identify any substance, a molecule, a compound, or an element by knowing its specific heat. You cannot identify an element in this chapter by its mass, how much heat it produces, or what the temperature changes. It's always coming down to the specific heat, not even the heat capacity. It's the specific heat. So that's what this table is all about. This is the table 5.1 that they're talking about. So I'm just going to look for my specific heat number. The specific heat was 0.39, and I see the closest one is copper, right? 0.385. So this substance is copper solid, or, just copper, whatever you want to say. And it kind of makes sense, right? In the beginning, it said that it was an unknown solid substance, so it has to be a solid. And in this case, yeah, copper is a solid. So that's it, guys. Hopefully this helped. B is done with. That one was easy. Let me know in the comments what you thought. Give this video a like. Subscribe to the channel if you want to help us out. Thank you so much for that. You guys are awesome. Keep studying hard, and I will see you guys in the next video. See you soon. Bye.